Well, hi and welcome to my shop, and once again I have this very nice Harman Kardon receiver in front of me to do some work. And the reason for this is I did a little poking around off camera, and I performed a test which I'm going to repeat here and pursue, which has revealed something, and I don't know what yet. So I'll just recap. While I'm setting up here, I'll recap where we're at with this very nice AM/FM receiver. And I think I called this a Harman Kardon receiver on one of my videos. It's not. It's a Stromberg Carlson. And I like to switch those names around. So pay attention to me when I say them and ignore me shortly afterwards. So what we're going to do here is we're going to monitor the B+ voltage as the receiver warms up. And I'll tell you what I've noticed. I've noticed that in the power supply capacitors, the big, well now they're this one here, it charges up properly. It reaches pretty much the full voltage that's listed on the schematic, and then immediately falls off to a much lower voltage. And because it shows the high voltage briefly, it has restored my faith that I can track down the cause of this, mostly by doing circuit isolation, where I'm just going to remove various circuits in the radio, the high voltage circuits, and just wait till I remove the one that causes this drop in voltage. That's my aim. I've noticed that it doesn't matter how the radio is set, AM, FM, or phono or auxiliary, this voltage drops. That's as far as I did my testing before I realized I'm onto something here that's worth investigating, and I just as soon do it. Now, I did do one more thing too in the radio. This capacitor has been installed somewhat temporarily. I've just tacked it in order that I could get off another one of these original capacitor terminals. And I've just done it temporarily. Things are kind of floating in space here. Electrically it's fine. And I think the last thing I did, I just quickly poked my ohm meter. Let's put it here on this terminal and got a 0. That's not too good either. Yeah. So maybe in the end I'm just going to get off that capacitor entirely. Maybe that's the cause of the problems. Maybe I got fooled at the start. So I really think probably we should get off this capacitor here. And you know what? Maybe that's the end of the problem. So again, we'll do that kind of temporarily. Although I can't imagine I'm ever going to go back to relying on this capacitor at this point. I mean, once you've gone this far, there's no use hooking the old one back up. Now, the resistor here is a 30. Looks like a 390 or something like that. 390. A 390. I don't remember seeing a 390 anywhere. And it connects over to, it goes to ground. Maybe the resistor shorted. Yeah, I'm just looking on the schematic here, and I don't see any such capacitor. It's kind of weird. 390 to ground. Well, I could stare at this for quite a long time and not spot it. So we won't do that. Although I'm staring just for a moment longer here. Yeah, I don't see it. Yeah. Okay, it's not popping out at me. Well, you know what? We can do one more thing here. We know the two capacitors that I've freed up are this one, or freed up or replaced really, and this one, and then this is the last one. Supposedly 245 volts. 245 goes over here, and you know, I don't see any. Oh, look at that, there it is. What's that say? I'd say it says 330. Just let me get my bionic eye out here for a second and see what it really says. It's definitely 330. You know, it's not connected in the right place. Oh, wait a minute. Yes, it is. 25 microfarad capacitor. There it is. 330. And in here, that's definitely not a 330. Get a better view of it right here. Okay, it's that one. It's orange, white, brown. So you know what that tells me? That tells me that's been replaced. Or it hints that it's been replaced, and it just wasn't replaced with an exactly the right one. Yeah, let's see if it's 390 if I read across it. Okay. So it basically goes to ground. So look at that. Well, that might be reading 0 because the capacitor is actually shorted to ground. That's more likely the case. So let's nip that off and see what kind of readings we get. I am very much encouraged that I'm going to find the problem here. You know what? I don't know if I just want to nip that. There's not much wire left on it. Yeah, that's enough. Okay, let's make another measurement. So I've just cut away the resistor. Whoops. 420. .420. 330 on the schematic, 390 on the markings, 420 on the reading. 330 and 420 are fairly different. Oh, I didn't make the interesting reading here, which is, what about the capacitor? Oh. Let's remove the yellow wire that's going to it. I feel like an idiot, really. I mean, this is the kind of problem I should have found, you know, right off the bat. Okay, baby. What do we got here? Huh. 0 there. 0 there. That's good. That's good. Yeah, good for how long? Well, you know what? I think that's the problem. I think I'm guessing. That's it. That was the problem. And it could have even been under low voltage, you read a fairly high resistance on that terminal. I'm sure I tested it initially when the first one showed a 0. I'm sure I hunted the others. You know, that's my excuse for missing it. You know, this is the problem with troubleshooting, is that if you go past the problem, if you misdiagnose or go past it, then in your mind you think there's nothing behind you. You've checked everything and you're just not inclined to go back and kind of redo everything. Not quickly anyway. I mean, eventually you will. If you're ever going to get the set working, you have to track down the problem. If you missed it, you're going to have to go back and find it. But that's how I find troubleshooting goes. I tend to get myself into a certain, I don't know, I'd say a mental picture of what's going on, and if there's something wrong with that, I think some would say there's lots wrong with Jim's mental pictures. So you can misinterpret everything after that. So the first misinterpretation leads to a whole bunch more. Okay, so what did I figure that capacitor was? What did I see it was? It was a 25 millifarads. And it would be very low voltage. You know, 20 volts. So what did I just say? 25 millifarads? Let's see what we've got. That's something like that. These are all 47 microfarads. Ooh. That's 1,000 at 25 volts. These are all pretty big, but I suppose I can put them in. Just quickly check the rest of my stock. No. You know, if you're going to try to stock everything you might need for this kind of work, you're going to end up with a lot of stuff. And a lot of these parts are really cheap, you know, diodes, resistors. These larger capacitors have a little bit of money in them, not much, but if you start trying to stock them, 2 and 3 of every reasonable type, you're going to end up with a couple $100 worth of stock that you probably will never ever use. And if you're doing one radio a month, you can afford to order the specific capacitor set you want, and, you know, replace them all, do that kind of stuff. I do need to maintain a bit of a stock, and often I don't have exactly what I need. So we're going to put in a 47 microfarad capacitor. And have some faith that that's going to work just fine. Now I got to find a good ground point here. There's one right there, but it's right on the chassis. It's a little hard to solder into it. It's in the ideal location though. Okay, let's try and do that, because I think I can really get this on there properly too. Soldering iron set on high. Should be hot enough and able to deliver enough heat. Let's see what happens here. Oh yeah, she's hot. Hot, hot, hot. Yeah, that's soldered on there just nicely. Better turn down my soldering iron or face the consequences. Okay, now I gotta swing this guy down here to kind of get it to... Now I'm gonna leave the resistor the same size. Now, one of my viewers was asking me about this exact kind of repair, putting in these kinds of capacitors, filter capacitors. Chip, I hope you're watching, because not only will you learn what to do, you'll also learn what not to do. Let me show you all the mistakes you can make here. That's part of my theme, I guess. Okay, so let's say... Yeah, it's always fun watching the other guy make mistakes, so... Okay. Okay, it's a little messy down in this area, but it's going to hold together. Okay. Connect right onto that spot. So I'm hooking up the meter over here. This one here. And check the scale up. Okay, so it's set to 500 volts full scale. So from where I have it connected, it should rise to about mid-scale and then perhaps fall back a little bit. Whereas what it's doing right now, if we actually, or what it was doing, is it would rise up like that and then just about as quickly fall all the way back to about 50 volts. And 50 volts seemed to be enough to actually operate much of this radio, believe it or not. Okay, I think we're ready for a test. Yes, sirree. I think we are. Here we go. It's plugged in. And just checking here for safety sake. Let's get this light around here. You can see the light when the radio's turned on. This light will be on. That'll help keep me at least semi-conscious of what I'm doing here. So, yeah, I had a rough night's sleep last night because of some cats that for some reason thought 5 in the morning was a good time to start playing. Yeah, I didn't think it was a good time, but they sure did. So if I say stupid things, it's because I'm actually half asleep while I'm doing this. So here we go. I'll put it on current restriction, just in case I've done something dumb. And have I done something dumb? Oh, you know what? Oh my gosh. Yes, I've done something stupid. Let's just back off on this test. Oh man, what an idiot. Yeah, see, that's from blame it on my cat. You can even explain how I made this mistake, which is always, if you're going to make a mistake, you better come up with an explanation. Here's the explanation. When you look at one of these capacitors, you can identify the negative lead because the negative bar is lined up with it. You can also tell because the negative is usually a little shorter than the positive. So I grabbed one of these. I went, okay, there's the negative bar. It lines up with this one. Well, you know, come on, it's a coaxial. It lines up with both of them. But I applied I can't remember what these are called. I applied the rule for these to these. Consequently, that capacitor is in backwards, and I came within yeah, let's pick on cats. I came within a cat's whisker of energizing it. Now that would have made a really good video, that's for sure. But I don't want to make those kinds of videos. Okay. Ring. I just won something. What was it? Now, I managed to clamp this down pretty tight, which means getting it off might be a problem. I could just stop this and go back to bed, but actually I'm kind of excited to get this done. Come on. Over there. Ah. Yeah. I am my own worst enemy. No doubt about it. And I've gone and I've shortened the wrong lead up too. You know, duh. Yes. I see another problem just developed. I'm gonna have to make a better connection on the other temporary connections I made for testing purposes. I gotta make them better because they're coming apart. This one right here is coming apart. Hey, we're going backwards. We're not going forwards. What a sad situation. Dummy. Okay, so what we'll do is we'll slip a little tubing on this long positive wire. It's another fine mess I've got myself into. Yeah, I could always just not post this video. Then you'd start thinking I'm a genius after a while. That guy never makes a mistake. I guess maybe, hey, I can still be qualified as a genius because I catch my mistakes. Or do I? Yeah, just for educational purposes. I did that all on purpose. It was actually not a mistake. That's not going to work. Oh. The lead has fallen off. And for my next capacitor, now, being very careful to be smart about this, there's the arrow pointing to the negative. There's the negative. You know what? I didn't like this capacitor anyway. Let's get rid of it. And there's another good reason for stocking lots of capacitors. Because you have a wreck-up rate. Yeah, geez, can you imagine being a, let's say, a heart surgeon, and you're trying to save a guy's life by stitching in a new heart, and you're having these kinds of problems. I certainly don't mean soldering, but I mean things are not working out right. You know, arteries aren't where they need to be, stuff like that. It must be harrowing to try that kind of surgery. I don't like how that worked. I don't think I got enough. I suppose lots of surgery is the same way. It's just, of course, heart surgery, it's kind of a do or die situation, I would imagine. Or like a heart transplant. And I know if I do make a mistake here on video, I can count on some of you viewers to point it out to me. Usually in an overly polite manner. Really, maybe it should be something like, you must be an idiot to have done that, but people are very polite. And they very carefully suggest I may have not done something. From what I understand, the head surgeon is a little like the pilot on an airplane. Nobody dare tell him his business, so people will stand will in the operating room be quiet while mistakes are being made. Ooh, that's a bad deal. Okay. Oh yes, this other jury-rigged connection here, which is just all tacked on. It's just this one connection right here. In fact, if I can loop the wire around it here a little bit. I know I'm so close to I think I'm so close to making this thing work. This thing being the radio. That I could easily rush to get this done. There, that's not bad. Not do as good a job as I should. Here we go. Goop this one up with a fair bit of solder. I see a little tail of wire that's driving me nuts. I'm going to get rid of it. There we go. Now, what we've actually done here is we've removed the connections from the original filter capacitor on 3 of 4 positions. We left the 4th one on, which is surely a questionable thing to do at this point. And once again, we are ready now for running our test. Put this right here. I believe that's the 245 volt spot. Once again, ready for a safety check. Did I actually put the capacitor in the right way? After all that talk. Yes, I did. This guy's ready, nothing shorted in there. We're all ready to go. Okay, and my bench is looking fairly clear. I gotta get some more of these capacitors, the filter type capacitors. Especially since I'm throwing them away now. Are you ready? I think we are. Okay, back to where we were. Switch is off. Power is on. Restriction. We'll go on. I don't think you can see the light. So let me, well, you know what you can watch. If I just do this a little bit. Now you get 2 meters to watch. You know what, there's nothing to watch here. I'm going to take you over and get you closer to those meters. Okay. I got so many things reflecting there. Now it's not enough light. There we go, a lovely view of the 2 meters. Okay, so this guy's reading the voltage being supplied at the end of my plug. And this guy's going to read the B plus 500 volt scale. So let's plug in the radio here. Incidentally, I am doing this with, yes, an isolation transformer in the circuit. If you don't believe me, there it is, right there. Isolation transformer. Still using the light bulbs though. And I'm close to acquiring a varactor to really get control over the power supply here. It'd be like my dream come true. So. But for now, so what we should see is, when I turn this head on, this should drop back and then come up fairly quickly. It's going to drop a long ways because the light bulb will be in the circuit. It'll come back up, and then it should drop. It'll go like this, boing, boing, up, and then drop down. At the same time, this one, as soon as I turn the power on, this will start climbing up fairly quickly, up to around here. If the fault is still in the set, it will then almost immediately begin climbing back down. If the fault is not in the set, it will stay here, and we have something to celebrate. So, ready for all this meter excitement. Here we go. I just have to turn it on here, that's all. Okay, so here comes the B plus voltage. This one's still down below 100. So we have 250. And will it stay? Oh my God, there it goes again. Huh. Oh, no joy. No joy to be had. No joy to be had here at all. Isn't that disappointing? So now we're down at 50 volts. I was not really expecting that. There's no use me applying full voltage, or is there? Well, let's do that just to see. So I'm going to flip off the light bulb, take it out of the circuit. This will jump up to 120 somewhere up here, and this we'll see what happens to this. Oh my God, look at that. Hey, we do have something to celebrate. That's the first time this radio's ever held this high a B+, and it's about it's 230, it's going up to 240. It's almost exactly right on that meter. It's supposed to be 245, and that meter's reading 250. This isn't the most accurate meter. Hey, thumbs up. Now, come back here. Okay, let's hear what we got. Wait a minute, we can't hear anything. I don't have a speaker connected. What am I hearing? Do you hear this? Yeah, no antennas in here. Yeah. Well, let's connect the speaker. I think that would be a good idea at this point. Yeah. We can leave it operating. I must have been hearing the output transformer. Sometimes the output transformers make sound. They're like a really crappy speaker if you think about it. A really crappy speaker. So while you're thinking about that, I'm going to hook up these wires here and give us a chance to hear this thing. So that's what it was, you know, a shorted capacitor. You know, and how stupid am I? I very quickly detected the one section shorted. Somehow, either I missed the other section that was shorted, or it only shorted when voltage was applied, or it literally failed in the middle of me trying to fix this radio. Let's see, the old adage is don't look for any other reason if stupidity can answer it. And you know what stupidity can? It is simply stupid and failed to check carefully enough the rest of the terminals on that capacitor. And it sent me off on a wild goose chase through the radio. And nothing I can find can explain what's going on, because there's nothing in the radio that will explain what's going on. It's all back with that supply capacitor. So, I mean, the benefit of these kinds of things happening is that it forces you to think really hard and explore the radio you're working on and become more comfortable with some circuits you've never seen before and all that kind of stuff. Yahoo to that, so getting some education out of it. But I guess the real frustration would be never finding the problem. Okay, so I got the speaker on. I should stop talking. I'll let the radio talk. There we go. Oh, I guess maybe it wants an antenna. Let's go AM. Oh. Yeah, I think we've got to put an antenna on it, because we're not going to get so far like this. We'll put it on the FM side. And another admission I have to make here is the previous tests I did on this radio with the my external house antenna. In fact, antenna was not connected. Disconnected in my office so I could connect up other radios, and then I forgot. So the line coming into my shop here isn't going anywhere. So I did a few tests thinking I had an antenna when I actually had no antenna. So I'm going to go fix that. Okay, so I'm plugged in here. We'll go on the FM side.
That they did talk them meeting each other. And in this case, it was tens, scores, hundreds, and probably thousands of people who found that the church was very obstructive in helping them trace either their mothers or their children. And
so I'm going to go and just connect the antenna properly.
8 or 9 years when I was involved in the sort of detective work, the church again was very obstructive. So that's the first one. The second one about the donations is very interesting. I think the spokesperson for the order said two specific things they denied. One was that they ever took donations, and two was that they ever destroyed records. Well, the nun who oversaw the adoptions at Shamross Abbey, which is the place where Philomena was, when she was on her deathbed, she knew she was going to die, she got something off her chest. She sat down with a social worker and said, I want to tell you two things. One is that I personally destroyed records relating to the adoptions of children from the Abbey, and the other one is that the donations, in other words the payments from the adoptive parents, most of them from the United States, were the convent's largest source of income for the years during the were taking place. So
that's incredible.
On a factual basis,
it's not on the best speaker.
Those claims are wrong. What the church
presto, we got it
of course,
fixed.
is that it was a different time, it was a different society, it was the 1950s, values were different.
It should have taken me 10 minutes to fix.
We did things then that perhaps we wouldn't
hours.
do now. But the most powerful thing they could have done in all of this, I think, is to say, sorry, we're sorry.
Pretty good volume.
We're sorry for what we did, and we'll now try and do as much as we can.
Now, sometimes I get copyright claims when I do this.
Every Friday, 7 p.m.
On Gillingham Road, south of Bailey. Must be 18 years or older. Know your limit. Play within it.
You smell that? It's got to be Christmas time at Voss Independent. That's the smell of delicious deals. Samples featuring
the smell of delicious deals. It seems pretty good. Let's try the AM band. Lots of noise. Oh, you know what? Could be, let's see, I think we're on this loop antenna. Yeah. Seems fairly well tuned. Picking up lots of strange things, but no AM signals. Okay, well, I think I'm going to stop for a minute and savor my success. Notice the B plus went up a bit when I put it on AM, because the FM introduces more tubes, pulls the B plus down, and it'll go even higher if I put it on auxiliary, I'm pretty sure. Look at that, 300 and, wow! 310 on the meter there. And the audio sounds really good. There's no power supply hum at all. So, hey, success, a little round of applause. And I just have to think about whether I want to try an alignment on this set or not. Maybe a good thing to do would be to try it out in my office and get out of the shop here, because it just seems to be too much noise in here all the time. Yeah. Or, wait a minute, wait a minute, one more thing. No reason why we can't quickly connect the outdoor antenna. So that's really easy to do. Right now it's on the FM side. I'm just going to jumper it over onto the AM side. Okay. Oh yeah, well, back on AM. AM. So there's a station right there. One right there too, but the noise is winning the day, so I think I'll probably have to do some kind of alignment, but for now I think, once again, another round of applause, and I think I can consider this essentially repaired at this point. Hey! So see you in the next video when I do the alignment.